Hello guys, what's up? This is Murtaza. Thank you again so much for joining me in this video. As you already know, in this playlist, we are talking about the most important principles in developing robust and successful software applications. I hope you have already watched the previous videos. If that's not the case, as always, go through them, watch them. They're very important. In this video, I have decided to talk about the last principle in solid, the five most important principles when it comes to developing successful object-oriented programs. The last D in solid is for dependency inversion, right? DI. And dependency inversion is related to dependency injection, which is a design pattern, and I am going to talk about it. And also the principle of inversion of control, right? And I will probably make another video about inversion of control. So inversion of control, dependency inversion, and dependency injection, which is a design pattern, they are all related. But in this video, I will concentrate on dependency inversion because I want to cover the five principles in solid. We have already talked about single responsibility principle. We have talked about open-close principle. We have talked about least cost substitution principle. And here we are going to talk about dependency inversion principle. And I forgot, we have also talked about interface segregation, right? So dependency inversion principle. Let's go on and see what this is all about. Dependency inversion encourages abstraction and decoupling in software development. Instead of high-level modules depending on low-level modules, both should rely on abstractions. This concept is part of the broader dependency inversion principle. Now, there are some entities, some ideas and concepts in this definition which I want to talk about. First off, high-level modules. So high-level modules, let me give you an example to make this clear. Suppose you have a class, right? And this class is making use of another class. So basically, it is instantiating or creating an object of the second class, and through that object, it is doing something. For example, it is calling one of the public methods of that class. So in this scenario, the class which is being instantiated is the low-level module. And the class which is instantiating the other class is the high-level module. So in this scenario, the high-level module and the low-level module, they are dependent on one another. So the high-level module depends on the low-level module. So it is having a dependency, or that object that I talked about is having a dependency on the low-level module in order to do whatever it wants, right? In order to accomplish the task that it requires, it is creating an instance of the low-level module and then calling a public method from the that object. So basically, dependency inversion tells us that this is a bad practice. So we shouldn't have high-level modules which are dependent on low-level modules, but both of them, high-level modules and low-level modules, should depend on abstractions. Now, abstractions is a very overloaded term, right? It has many different meanings, but in C#, for example, abstraction can be an interface or an abstract class. What does it mean to make those high-level modules and low-level modules dependent on abstractions rather than on one another? So basically, in that example that I told you about, if I want to implement dependency inversion, it means that the class which is acting as a dependency, the second class, should implement a specific interface. And then the class that depends on this one should take in an instance of the interface in the constructor. For example, I'm making it very simple to understand, right? I am not going through all the details of dependency injection and the ways that you can make instances of the classes that you are dependent on. So basically, let me say this one more time. The class that you depend on should implement a specific interface, and then you that have a dependency on that second class should do what you want to do, not by implementing or instantiating an object of that class, but rather through that interface which is implemented in the dependency. So basically, this means that both of the classes rely on abstractions. One of them by implementing that abstraction, which I told you in C# could be an interface, but the high-level module by introducing an object of that interface rather than a concrete object of that class. So the concept is part of a broader dependency inversion principle. I will probably add more videos to this playlist talking about the dependency inversion and also, as I told you, dependency injection, which is the design pattern. Anyway, let's go on. And in this slide, I want to talk about the advantages of dependency inversion. Dependency inversion. What happens when we follow dependency inversion? And dependency inversion can be achieved through different means, through different design patterns, like, for example, the strategy design pattern, the service locator, which I will probably make videos for. But one of the ways to implement the dependency inversion is the dependency injection principle. Anyway, advantages of dependency inversion. First, flexibility. So by relying on abstraction, changes in low-level modules don't affect high-level modules, right? Enhancing flexibility. I have told you before that in software development, we are in favor of loosely coupled modules. So what we prefer is that when we make a change in one of the classes, that change doesn't get propagated to other parts of the project, right? So the modules, the classes should be loosely coupled. So through dependency inversion and through using abstractions, when we change something in the low-level module, the module which is acting as a dependency, this change doesn't propagate to high-level modules. Why? Because the high-level module is not directly dependent on the low-level module, but rather on an interface. So as long as that interface remains consistent, nothing will have to be changed in the high-level module. Number two, scalability. It supports the scalability by making it easier to add new functionalities without disrupting existing ones. So whenever you want, you can either declare a new dependency by deriving from that interface, which we talked about, that abstraction, without touching the pre-existing dependencies, or you can change, right? You can change some pieces of code in the pre-existing dependencies, and since the high-level module is not directly tied to the low-level modules, it will remain intact. Testability. Code becomes more testable, as dependencies can be easily substituted with mocks or stops during testing. I have created a playlist about unit testing in C# with XUnit. And we will talk about mocks, stops, spies, and so on in that playlist. But be aware that using a dependency inversion and making our high-level modules dependent on abstractions rather than the low-level modules will make the code more testable, which means that whenever we want to test that high-level module, we do not have to make objects of those low-level modules of our dependencies, but rather we can use frameworks like mock or nsubstitute to make fake versions or mocks of those dependencies. We can also configure the behavior of that mock version of the dependency and then test that high-level module in isolation. I think if you watch the videos about unit testing in the playlist about unit testing with XUnit on my channel, everything about this testability will start to make more sense. The last one, reusability. Abstractions promote code reuse, as high-level modules can interact with various low-level modules through a common interface. So as I told you before, when your high-level modules are dependent on abstractions, if you want to introduce a new dependency, all you need to do is to follow OCP, open close principle, make a new class, which implements that abstraction, that interface. You don't touch the high-level module because that depends on the interface, that's it. But you implement a new class, you implement that interface, and then you write custom code for the methods in that interface, in your abstraction. So this promotes code reuse, which means that high-level modules can interact with various low-level modules through a common interface. So as I told you, as long as the code in the interface remains consistent, changes in dependencies do not propagate to high-level modules. As I have told you before, this dependency inversion is very important, and it is related to dependency inversion principle and dependency injection design pattern, which I will probably make videos for, but I want to finish this video right now. If you have anything to say, please leave a comment in the comment section, give this video a thumbs up, share it with a friend. I would really love to hear from you guys, because that not only promotes the channel so that more people can watch the videos, but also it keeps me motivated and it helps me know that you guys are enjoying the videos. If you want something to learn about, if you want to tell me to, for example, I don't know, Mortaza, make some videos about this topic, about that language, about that technology, just leave a comment in the comment section and I will put it on my to-do list and I will try my best to make a video out of it. Thank you again so much for sticking to the very end. Stay tuned. In the next video, I'm going to talk about keep it simple or stupid, which is another very important principle in software development. Till later, bye-bye.